Hi, this session will be on test corrections on the test you had on SURDS and index laws. It's a test similar to this one. It may be a bit different, but most of the questions are the same to the test that you had. Now, with the first question, it asks us to explain the difference between rational and irrational numbers. So I've written an explanation here, which you can have a read, and I'll just explain what I mean by this. So rational numbers are numbers that can be turned into fractions, and the reason is they are either numbers that are whole numbers, or if they have a decimal, the decimals they can stop, which means we can say finite, which means it has an end. For example, 2.5, I would say, is a finite decimal. Or if their decimal never ends, just say you have 1/3, 1/3, which is 0.33333. That goes on forever. Because there's a recurring pattern, it can still be turned into a fraction. So as long as your decimal stops or it has a pattern, like that example, 1/3, 0.33333, then it can be turned into a fraction, and therefore we say it's rational. Okay, and it sort of makes sense. Rational means to make sense. However, irrational numbers are numbers that can't be turned into a fraction, and that's because they are decimals, so they have to be decimals that have an infinite decimal but no recurring pattern. Okay, if their decimal has no pattern, then they can't be turned into a fraction, and therefore they are irrational. And SURDS, because our topic's on SURDS, I've included this part in. And SURDS are an example of irrational numbers that have a radical sign. So for example, if you push in the square root of 2 on your calculator, you'll have an infinite decimal. The calculator obviously stops at a certain point because it can't fit too many numbers on its screen. But if you can't get rid of the radical sign, you have a SURD. I know the square root of 4 is 2, the radical sign disappears, and therefore it's not a SURD. So just keep that in mind, and hopefully that makes a bit of sense. So using our knowledge over here, we can answer the following questions. And this question here asks us, state whether each of the following numbers is a SURD or not. Now, if you have a look at the first one, so basically with A, B, C, and D, if you have a calculator, you can just put it in your calculator. If your answer is a long decimal that you can see has no pattern, therefore it's a SURD. If your answer is a whole number, then it's not a SURD. So we can put these into our calculators, and if you don't have a calculator, you can just work it out, I guess, mentally or by writing out a few multiplication problems. So with A, we've got a 2 out here, that's fine, but the problem is 625 a number that's a perfect square? And I know that 25 times 25 is 625. So the square root of 625 is 25, and 2 times 25 is 50. So if you use your calculator, you would have had an answer that's 50. You can see it's a whole number, so therefore this one we would say is not a SURD because we got a whole number as an answer. B, straight away I know if I put this in my calculator, it will equal 20. You can go 20 squared is 400, and a square root of 400 is 20. But a trick is if you see that square just here and a square root together, they cancel out and you're left with 20. So this one here is also not a SURD. So not a SURD, not a SURD. C, once again, now have a look here. This is not the square root, it's the cube root. There's a 3 out there of 343. So is there a number times itself 3 times to give you 343? And I know that 7 times 7 times 7 is 343. So this is not a SURD because it equals a whole number 7. Now with D, I've got a 4 out here, a power 4. So it's saying the 4 root of 100. So is there a number times itself 4 times to give you 100? And I can't think of a number, even if I start from 2 and work my way up. There is no number times itself 4 times to give you 100. You enter this on your calculator and you get a decimal with no pattern. Therefore, this is a SURD. So yes, it's a SURD because we can't get a whole number or a finite decimal as our answer. Now, with this one here, classify the following as numbers as rational or irrational. So if we have a look with A, we've got 6 and it goes on 2, 2, 2, 2, 2, and it tells us that it continues. Now we can see the decimal will never stop, it's infinite, but I have a pattern, and my pattern is 2. 2 keeps repeating itself, so therefore this one is rational. The square root of 8, now once again, square root of 8, is there a number times itself 2 times to give you 8? No, there isn't. 2 times 2 is 4, 4 times 4 is 16. So 8, I can't get a whole number, so this one is irrational because we can't get rid of that radical sign. So that's a surd. This one here, we've got 0.235. The decimal stops. Our explanation here uses the keyword finite. So therefore, because it stops, it's rational, and this can be turned into a fraction. And with D, we've got a negative half. It's already a fraction, so straight away we know it's a rational number. Okay, so the only irrational number was the square root of 8, which is a surd. Now, with next one, it asks us to simplify the following, and we have a few square roots here, so I'll just write them up. Okay, so to simplify the following, yes, I can see these, well, this one here and this one here, with 8, it's a surd. Square root of 12, there is no number times itself twice to give us 12. Okay, and just remember, to work these ones out, you have to remember the perfect squares. And perfect squares are numbers that are multiplied by the same number, and that's our product. And perfect squares are special because there are an infinite amount, but at the beginning, when we have small numbers, there's only a certain amount. So we start with, really, we know 1 times 1 is 1. So 1 is our first perfect square. And then from then on, we have 4, 9, 16, 25, 36. And you can see that they start getting larger and larger and larger. So 4, 9, 16, they're our smallest perfect squares. And they come in very useful when simplifying small numbers like these ones. So to simplify the square root of 12, we have to think of factors of 12 where one of them is a perfect square, at least one. Otherwise, we can't simplify. So I know that 4 times 3 is 12. Oh, sorry, I should have written 4 first. I'll just rub it out. Doesn't really matter, but just makes it neater. So 4 times 3, I know is 12. And now I can separate these two numbers, so I can have the square root of 4 times the square root of 3. And now I know that the square root of 4, I can work this out. It becomes a whole number 2. And then the square root of 3, it's still there. It's still a surd. We can't get rid of it. Sorry that it's squishy. And that's our answer, 2 square root of 3. Don't forget there's an invisible times in between the 2 and the square root of 3. You can see that this is still a surd. We haven't gotten rid of our sign, of the radical sign, but we've just made it more simple and made our numbers smaller. Okay? And just remember, to do this, you have to find factors of the number you're dealing with that's a perfect square. If there are no factors that are perfect squares, then your surd can't be simplified. So this one, 125, if I have a look at my perfect squares here, I reckon 25, which is a perfect square, might be a factor of 125. And I know that 25, so don't forget your radical sign, 25 times 5 gives me 125. And now I can separate these two. I'll just write this off and write it again. Separate them. Now you can skip this step if you want to. Okay, this is the same as having them separate. We haven't changed anything. This is the same thing. And the reason why we separate them, because now the square root of 25, since 25 is a perfect square, and I know that 5 times 5 is 25, the square root of 25 is 5. And if you've forgotten how to read this, remember there's an invisible 2 out here saying a number times itself twice to give us 25, the number is 5. And we can see it down here. And times the square root of 5, we can't simplify the square root of 5 anymore. And so our answer is 5 square root 5. And we're done. With C, we've got 6 times the square root of 8. Now, don't forget this 6 out here. All we're saying is 6 times, and if we're able to get it a whole number, then we multiply it with the 6. Now, the square root of 8, I know a factor of 8 is 4, and 4 is a perfect square, so I'll use my 4 times 2. Separate them. I might just skip that step so I have more room. So imagine I separated them. Okay, square root of 4 is 2, so I have 6 times. That sign is now gone because the square root of 4 is a whole number 2. But this one here, sorry, I forgot to write it, is still the square root of 2. So times the square root of 2, and that's our answer. And the multiplication becomes invisible. Oh, sorry, and of course, 6 times 2 is 12. Forgot that bit. And square root of 2 sits there. Just squeeze it in. So that should have been your final answer, 12 square root of 2. And don't be confused if you have a 6 out here. You're just saying 6 times whatever number you can turn into a whole number. Okay? And I write the last question up. Now with D, we have a negative 2 on the outside. So just remember, leave it there for now. It's saying negative 2 times the square root of 50. Now, 50 is not I can't figure out the square root of 50. It's a surd. But I know a factor of 50 is 25. So I'm going to write minus 2 times the square root of 25 times, and 25 times 2 gives me 50. Okay, so 25 times 2, I still have 50, but now the square root of 25, because it's a perfect square, and I know 5 times 5 gives me 25, I have minus 2 times 5 times a square root of 2, and minus 2 times 5 is negative 10 square root 2. And we're done. So it's negative 10 square root 2. Let's move on. Now, our next question will be simplifying the following. We can see we're now adding or subtracting surds. Now, this is just like algebra. It's like adding x's with x's and b's with b's, but instead of variables, we have numbers under a square root. So it's just the same as algebra. Now, if we have a look with this one, it's like I have 5x plus 1x plus 2x. But instead of x, I have the square root of 3. So basically, how many of these do I have? Just add the numbers in front. And don't forget there's an invisible one in front of this 3. Okay? And if you're not sure what I mean by algebra, imagine we had this. Just imagine we had 5x instead of the square root of 3. Plus x, which is just, we know there's a 1 there, plus square root of 3 again, so plus 2x. So imagine I said x is equal to the square root of 3, just say, and you know how to do this. We've got 5x plus 1x plus 2x, so 5 plus 1 is 6, plus 2 is 8x. And that would be our final answer. But instead of x, we have the square root of 3. So our answer will be 8 square root of 3. I have 8 of these, and that's all we're doing. So always check your operation, because if you have addition or subtraction, you can only add the like terms, so the same surds. And sometimes you have to make sure they are simplified into surds, and yeah, continue from there. Now we'll do question B here, which is quite a long one. So I have drawn it, but this is probably a bit more neater for you to see. And this is just check your operations. You can see that we have negatives and positives, or addition and subtraction. There's no multiplication anyway or division. So we're just adding or subtracting the same surds. Now these ones are all surds. So just do a check, except for the square root of 4. I know the square root of 4 is 2. So that could be my first step, just to highlight that the square root of 4 here is actually a 2. That was the only one that wasn't a surd. So now just work with one thing at a time, and be careful with your negatives and positives. So if this helps, always start from the end on the right hand side and circle to the left. And we do this a lot. Just in case you make a mistake with your negatives, it's fine to do this. It's part of your working out. I'd rather you do this than get confused with your negatives and positives. And of course, it's easier to do this on paper. That's a negative square root of 2. That's a positive 7. Okay? And now I can't make any mistakes with my negatives and positives, and I'll get the right answer. So now, one thing at a time. Now your whole numbers, see this 7 by itself, and that 2 by itself, which is a negative 2. I can, also we have a negative 8 here. So just be careful and double check what you have. So I've got three numbers, 7, negative 8, and now it's a negative 2 that are whole numbers that I can add together. There are no surds attached to them. And working from left to right, 7 minus 8 is negative 1. So that's negative 1. And then negative 1 minus 2 leaves me with negative 3. So please be careful with your negatives. So once again, 7, positive 7, minus 8 is negative 1. And negative 1 minus 2 is negative 3. And just remember, square root of 4 is a 2. That's how that 2 got there. Next, I will focus on the square root of 2. So I've got a square root of 2 here. There's my surd. Do you see any more square root of 2's anywhere? No. Yes, there's one here. And that's it. So now, don't forget there's a negative here. And it's really a negative 1. So what is minus 1 plus 7? Minus 1 plus 7 is positive 6. So we now write positive 6. And what do I have here? Square root of 2. And cross it off. We've done that. Use it. And I can cross off my 7 and my 8. Okay, next. What surd do you see next? We've got the square root of 10. Any more square root of 10s in the whole thing? That's all that's left. So it's a positive 3 minus 4. 3 minus 4, I know, is negative 1, which can be invisible. Square root of 10. And that's our answer. There is nothing else we can add together. And we have simplified this as much as we can. So the only mistakes you would have made was, 1, forgetting that the square root of 4 is actually 2, which is a whole number. And of course, mistakes with your negatives. Now, I know this looks a bit messy, but if you did this on paper, it would be pretty straightforward and pretty neat. And I really don't want you to make any mistakes with your negatives, especially if you can do the easy thing and just circle what belongs to what, always to the left. Our next question is this one here. Simplify the following surds. And if you have a look at our operation, we now see multiplication, okay? There was no multiplication with these ones up here. So now we're going to be doing a different thing, having a different approach. So here are my questions, and it's asked us to simplify. When you see multiplication, all you have to do is multiply numbers on the outside with each other and numbers on the inside under the radical sign with each other, and that's it. And of course, simplify if you can. So I have no numbers out here, so 1 times 1 is just 1, and then 5 times 7 is simply 35. And just check, can we simplify 35? Is there a perfect square that's a factor of 35? Let's just check. So 4 can't go into 35. 9, no, 9 can't go into 35. 16, no. And I don't think there are any perfect squares that are a factor of 35. So we stop there. This is a surd that cannot be simplified anymore. And we're done. Down here, now it's a bit different because we now have numbers on the outside. So the 6, there's a 1 there, which is just going to be 1. But 6 times 1 is 6. And 6 times 3 is 18. So on the outside, my whole number is 18. Under the square root, I have now 5 times 10, which is 50. And 50 times 2, which is 100. Okay, and we're done when it comes to multiplying and simplifying this part here. But just double check, what do we have here? The square root of 100. I know the square root of 100, this is not a surd anymore. Square root of 100 is simply 10, because 10 times 10 is 100, so that equals 10. And don't forget we have a times in between the 18 and the square root. So we have 18 times 10, and 18 times 10 is 180. So that should have been your final answer. Just remember, always check and see if you can simplify whatever you have any further. Now, our last 2 questions for this session, we're only doing the surd component of this test. We now notice we have these surds in fraction form. And don't forget that fraction, we're actually dividing. Okay, so I'll just write the questions down. So with these ones, you just have to remember that rule when it comes to surds and dividing surds, and that is, if we have the square root, just say we'll use variables instead of numbers. If we have the square root of a over the square root of b, okay, that, I guess, law of surds says we can, because they're both surds, we can combine them under one big surd. So we've got, or radical sign, sorry. So a over b. And the reason for that is now because they're under one, if my a, just say, was 20 and my b was 10, I can now easily go, well, 20 divided by 10 is simply 2. And I can simplify it in a much easier way. Just remember, this radical sign doesn't disappear. 20 divided by 10 was 2. I still had to keep my radical sign. But you have to remember this law that we can do, that rule, and that is if you have two separate radical signs or square roots, you can combine them under one big one when you have a fraction. That's if they are both under the square root. So if I had, for example, if I had a and on the bottom I had a square root of b, okay, because they're not both under the square root, I can't simplify I can't combine them under the same one. So I'll just leave this like that. This cannot equal that because they are not both surds. They're not, both surds, or they don't both have the radical sign. All right, so with these questions up here, well, my first step for this one will be, let's combine them under the same radical sign, and we have 70 over 80. And now we simplify this just like a normal fraction. I can chop my zeros off, and I have 7 over 8. Now, the next step is, yes, we've done that, but I'm going to put them back into their separate radical signs. And the reason for that is the square root of 8 can be simplified further. I know the square root of 8, I'll continue it up here, I've got square root of 7, it's a surd, I can't simplify it anymore, but the square root of 8, I know that 4 times 2 is 8, and 4 is a perfect square. So on the bottom, I'll have square root of 7, and imagine I separated these. The square root of 4 would leave me with 2 square root 2. And that should have been your final answer. Okay, doing this step here is fantastic, but taking it further, you're showing me you have a better understanding on how to simplify surds. Okay, so just remember the square root of 8 can be simplified to this here.